add or subtract fractions. So we already did this once. But the first section that we did this in, all of the denominators were already like denominators, so they already kind of did the work for us. So, same concept here. We still need a common denominator. And again, I'm lazy, so CD is going to mean common denominator.
You need to start it.
Oh, thanks. So we need a common denominator, and that's kind of where we're going to look at and concentrate on today. But after that, then, you need to, before you add or subtract, you need to recognize signs. So look at signs. This simply means to go through all the rules that we, talked about previously when we're adding and subtracting. If the signs are the same, we add and use that sign. If the signs are different, but we're adding, we actually subtract and then use the sign from the bigger number, right? And we say it that way because even though that it's a negative number, we know that that can never be bigger than a positive number, but we would use it because. And then with subtraction, I think most of us are getting used to subtraction, so you can think of it as a true subtraction problem, but if you still need to, you can keep change, or add the opposite and change the signs, okay? In either way, as we're looking at the signs, we're figuring that out, and then we're going to add or subtract. And when we add or subtract, it's only the numerators. So we're only adding and subtracting the top number, the bottom number stays exactly how or what it was. And that's that common denominator. So again, we did this in a previous section, but all those denominators were the same. So before we do our process, then we have to be able to find a common denominator. Now again, notice that I said the common denominator, not the least common denominator. This is where you can do work at the beginning or work at the end. So if I want to find a common denominator, we kind of looked at that process this morning, right before we started this, by doing those review problems. Okay? Easiest way for me again to do this is what? To find a common denominator? Yeah, just multiply the denominators together. Now, advantage of this, I don't have to think a whole lot. Disadvantages of this would be what? Okay, I got to reduce at the end. It could come out to be a really, really big number, and then I have to make sure that I manipulate or change that top number from my denominator. So, what are the advantages of finding the least common denominator? Then I don't have to worry about reducing at the end. Okay? But again now, if I go through the process of finding the least common denominator, then I actually have to do some work at the beginning, right? Because I might have to do that prime factorization. I might have to, actually stop and think. And some of us don't like to do that a whole lot. Right? You do? Yeah. Okay. So, we can use any common denominator that we want, or we can try to find the least common. That's totally up to you, how you want to do it. If I have mixed numbers, what's a mixed number again?
Big number and then
So give me an example of a mixed number.
3 and 1.
1 and what?
1/4.
1 and 1/4. Okay. If I have mixed numbers, I'm always converting to improper fractions. Now, why do I say always? Because you could still try to attempt to do this with the whole numbers and the whole numbers and the fractions and the fractions. But if you don't include that whole number with your fraction and you try to do them in separate parts, you might have to go and borrow to do the fraction part when you get your common denominator. So then you're going to bring that whole number into play anyway, and it gets kind of confusing. So I would just take the process and simplify it by converting it to improper fractions every single time. And what's my process for that?
Multiply the number times the whole number, and then add the number on top.
So 1 and 1/4 turns into 5/4, right? And then I would use 5/4 in my problem. Remember, any whole number, I can always make it into a fraction by doing what? How do I take 8?
Put 1 under it.
Yeah, so whole numbers just make it into 8/1, okay? And then remember, anytime that I have the number 1, I can always make it into a fraction by taking any number and putting it over itself. Agreed? So, in the original problem, if I have 1, remember, I can put 7/7, I can put a 5/5, it doesn't matter. 123 over 123, they're all equal to 1. And that would be an advantage to see what the other fraction is, or what the denominator was for my other fraction. Okay. So, we start out and start looking at some examples. 1/6 plus 7/15. So again, in my way of thinking of this, I might not necessarily do the least common denominator, or I might not necessarily do this right over here where I'm just going to multiply my denominators together. I'm probably going to do a combination of both. And again, this is going to help you this is going to get easier and easier for you the more and more times that you do this. You're just going to get used to looking at some numbers that go together, and you'll understand that, well, the common denominator between those two numbers is always going to be this, because you're going to see it so often. So, again now, what do you want to do for the common denominator? 30. Everyone, or a lot of people said 30 right away. Is this my least common? I have no idea. But it's definitely not this denominator over here, is it? Because if I multiplied 15 times 6, it would be what? 90. Okay, so we definitely didn't use the one that we multiplied together, but I think it's probably the least common also, right? I don't think there's anything else that we could have done. So then after we figure out a denominator, then we just start doing what we did the other day when we were going to compare them. So we have to do this part. So what did I do to 6 to get to 30? Multiply by 5. Now here again, here's another advantage, I guess, if you did this process over here where you just multiplied them together. When you're doing this part right here, where you're converting the top, or I like to call it manipulating the top, you would just take the numbers that you multiplied together and then crisscross them for the numerators. You know what I'm saying? So if I would have multiplied this by 6, I'm going to multiply this by 6. And this by 5 and this by 5, or sorry, 15. Because I multiplied those two together. You see what I'm saying there? So that's, I guess, another advantage of this, that you always know what you're multiplying by. But again, if you're going to use a smaller denominator or even the least common denominator, it's probably something that you can really see anyway. So it doesn't really matter. All right? So I'm going to take the top number by 5, and I get 5. And then over here from 15, what did I do to get to 30? Multiply by 2. And so we get 14, and then we're going to add them together. Now again, we're adding, so we only do the numerators. So 14 plus 5. 19 over 30. Now again, realistically, if we use the least common denominator at the end, we shouldn't have to go back and reduce, like Mr. Kolbeck said at the beginning. But just take 2 seconds and look at your answer and make sure that I can't do anything else to that number, meaning reduce. Okay? So, again, not a horrible process, you just gotta make sure that you go nice and slow. So let's try a couple more. Negative 5/6 plus negative 3/10. Now again, if I'm going to do negatives, I would always put the negative symbol on the top or in my numerator. Remember, because we could put it on the bottom, we could put it out in front. I would just make sure that it's always with my numerator so I know where it's at. And now I'm going to look at it. Common denominator between 6 and 10. We could use 30 again, or I could have used 60, right? But let's use 30. Smaller, the better. So what did I do to 6 to get to 30? Times 5. Negative 5 times 5. Now here, again, I don't like multiple signs. So if you don't like multiple signs, you could just write this as one minus sign, right? Take this negative and put it out here. But if that confuses you, what did I do to 10 to get to 30? Times 3, so we get negative 9. And then last but not least, we add still because the signs are the same. So what's negative 25 plus negative 9? Negative 34 over 30. Now, this is the one that we're talking about, right? Realistically, I think 30 is the least common denominator again, right? I don't think there's anything smaller than that. But notice my answer this time can be simplified. So don't forget to do that. So what do we get?
Negative 16 over 50.
Is that right?
Negative 17.
Thank you. Don't forget your negative sign. Okay? And we'll get our answer. Questions here? All right, so then we could have mixed numbers. 2 1/8 plus a negative 3 2/3. So again, I'm not going to think about separating them whatsoever. I'm going to think about turning these into improper fractions first. So my first fraction turns into what? 17/8. My second one? 11/3, and then put your negative back on. So notice, again, this is really high emphasis. When I'm turning my mixed number into an improper fraction, don't use the negative in that process, because if Addie would have used that negative in the process, we would have got a different number, right? Because that would have been negative 9 plus 2, it would have been negative 7. So that's a big difference. Throw that negative out when you're doing that conversion, but don't throw it out completely. So now what? Common denominator. 24. Anybody use something else? What do we do to 8 to get to 24? 17 times 3. 51. 3 times what? 8, right? So negative 11 times 8? Now, when I add those two fractions together, what do I really do? I really need to subtract because the signs are different. Okay, so what's 88 minus 51? 37, positive or negative for my sign? Why? 88's bigger than 51, right? And last but not least, can I reduce? Really? Huh? 3? How many times does 3 go into 37? Right on. So I'm done, right? That's my answer. Okay. Questions here? So then we can do some subtraction problems. So we start out nice and simple. 9 over 16 minus 5/8. So this is a good one right here because if you look at my denominator, I can use one of my denominators, right? That's one of the things that when you start getting going kind of fast in your assignment, or when you start working on this worksheet tomorrow, you're gonna start going kind of fast because you're gonna get into a rhythm. Don't forget to look at the numbers that are given. So I could use 16 right away. If I don't notice that, my next one's probably what? 32, right? I could use 48, right? And that's not even multiplying them together. So there's a lot of them for those two numbers. So again, because I use 16, I have to use my numerator that was in the problem too. What did I do to 8? Multiply by 2, so then I get 5 times 2, which is 10. Now again, here's where you got to make a decision. Am I going to do keep, change, change? Or am I okay with just saying, I want to do 9 minus 10? That's totally, I'm not telling you how to do it, but that's totally how your melon works, right? So what's 9 minus 10? Negative 1 over 16. Don't forget your sign. Don't forget the denominator. Okay? So basically exactly the same thing that we did earlier. Except now we just subtract. So try this one all by yourself. 7 1/9 minus 4 5/6. See what you get. How'd I do? Did somebody not use 18? What'd you use?
I used
36? Anybody else?
I used 36.
Anybody besides 36 or 18? Still get 41 over 18? You just probably had to what? Reduce. And you forgot to reduce, didn't you? By the look in your face.
And now I'm realizing that I could have just used 8.
Oh, you're still reducing? All right, that's fine. Okay. More of those kind. Anybody? Yes? 4 2/3 minus 3. Let's do it this way. I know I'm changing it from what's up there. Well, let's do minus a negative 3 6/8. So again, I wanted to show you one of these because if I have back-to-back negatives, what happens?
Big positives,
What?
big positive sign.
A big positive sign, right? 2 negatives, turn that into a big plus. So essentially, I'm going to add those together. Try it out. Am I right? So this one was, I guess, interesting because the first common denominator that I saw is also the numbers just multiplied together. Because really I can't do anything besides 7 and 3. Okay. Again, you could flip this back and do a mixed number, but I would always leave things as improper fractions from here on out. So don't turn it back into. Everybody okay with that? Okay. So then obviously the other ones that we want to look at for today is story problems. Right? So Jane jogged 3.5 miles, 4 1/4 miles, 4 1/10 miles this week. How much did she jog altogether? So essentially all I'm doing is what? Adding them all together. So can I do all 3 of the numbers at one time? Meaning, can I find a common denominator for all 3 numbers? Yeah, I can do that. Or if that confuses you, just do the first 2 numbers and then get an answer and then take that answer and do it with the last one. All right? So try it out. See what you get. Add those 3 numbers together. How do I do?
Good.
So a couple things if you're still working. Because it's a story problem, at the end, this is one instance that it might be better to turn it back into a mixed number. Now again, we kind of emphasize not to do that all the time, but again, if I'm talking to people and they ask me, or if I ask Carver Ruland how much did he run this weekend, he comes back and said, I went 237 over 20 miles. Right? Probably doesn't make it. We still might not understand exactly what 11 and 17/20 miles means, but we know that it's at least way farther than I would ever run in my life. Right? Even splitting it up into 3 runs. Okay? Did I do it right? Okay? And then because it's a story problem, I always need a what? Don't forget your label. So I got to have my miles on there. Okay? Questions there? So, other story problem. Jessica needs 1 5/8 yards of fabric to make a vest. 3.5 yards for a coat and 2 2/5 yards for a skirt. How much fabric does she need in all? So again, all I'm going to do is what? Add them all together. Do we want to do this one? Yes, no, yes? Let's do it then. The most important part of this problem right here is what? Now, I don't think they would actually do this to you for where you're at in your mathematical lives, but what's the most important part of this whole problem right here? Realizing that it's addition, yes, is important, but even more important than that is that when they give you 3 different things in a problem like this, you gotta make sure that what? They're all the same label. Okay? So if they would have said that this was feet instead of yards, the first thing that I need to do is convert them all into the same thing. Now again, that's probably way ahead of where we're at right now, but just make sure of that, because especially in like algebra and geometry in the coming years, they'll try to fool you by giving multiple labels. But this time they didn't.
Oh.
Oh, what? So, oh, sorry. Don't forget this. Don't forget your yards. So I got 301 over 40. Anybody use something besides 40? So again, the same principle that we had written down over here, if I multiply them all together, that works for these too. So I could have done 5 times 8 is 40 times 2 is 80. I could have used 80. You know what I'm saying? Just because there's 3, that doesn't make any difference. Okay? So again, you're going to get a lot of practice of this. You're going to probably get old or sick of it in the next couple days or so. But this is a really important concept. You'll use this a lot with fractions. Okay? And not all the times will you have a calculator. Or we take your calculator away. And then if you don't know how to do it, then you're kind of up the creek, right? So, if you notice here, there's a quiz after this section, which means tomorrow, but we're going to do that review session first. So we'll do that worksheet tomorrow, and then the quiz will be on Wednesday. So if you got any questions with the paper worksheet, make sure you come to Jay's tomorrow and ask your questions. Again, it's not written up there, but I will not be around for Jay's. Any questions with anything?